In question 2, we turn our attention to the idea of continuity. And in part A, we're specifically asked to use the definition of continuity to determine whether the function f of x is continuous at the point x equals 0. And then, if it's not continuous, to classify it as a removable or a non-removable discontinuity. And any question about continuity always comes down to that definition of continuity. Is the function defined at the point? Does the limit exist? And are those two things equal? And so we'll just check each of them in turn until we reach the point where either we show that all three of them are satisfied or we discover one that is not. So first of all, is the function defined at x equals 0? Well, when x is equal to 0, we use the first of the two definitions of this piecewise function, because that works for x greater than or equal to 0. So if we substitute x equals 0, we'll get 0 squared minus 4 divided by 0 squared minus 0 minus 2. That's negative 4 divided by negative 2, which is 2. So yes, the function is defined at x equals 0. What about the limit? Well, this is a piecewise function, and specifically it's a piecewise function whose definition changes at x equals 0. So that means that in order to determine whether the limit exists, we need to consider the one-sided limits. So the left-hand limit as x approaches 0 of f of x, well, for x less than 0, we use the second part of this piecewise definition. So in other words, that's going to be the same thing as the limit as x approaches 0 from the left of 4 divided by x plus 2. Now that's just a rational function, so we can do direct substitution. We get 4 divided by 2, which is also 2. So the left-hand limit exists. The right-hand limit, well, there we're back to using the first definition again. That applies when x is bigger than 0. So that's going to be the limit as x approaches 0 from the right of x squared minus 4 divided by x squared minus x minus 2. But again, we can do direct substitution. And in fact, this is the same calculation we've got here. 0 minus 4 is negative 4, divided by 0 minus 2 is negative 2. Negative 4 divided by negative 2 is again 2. So because those one-sided limits are equal, that tells us that the full two-sided limit of this function as x approaches 0 that exists, and in fact is equal to 2. The fact that it exists means that the second part of the definition of continuity is satisfied. And the fact that it's equal to 2, since that's the same as the value of the function at x equals 0, that means the third part of the definition of continuity is also satisfied. The limit of the function as x approaches 0 is equal to the value of the function at 0. And so, f of x is continuous at x equals 0. So we don't need to worry about categorizing that as removable or non-removable at all. The function's continuous there. We'll continue on now to part B in the next video.